Hi everyone, we're about 30 seconds away from starting. I just thought I started 30 seconds early so we can make sure everything was ready to go. And so we'll now start in about 15 seconds. Dum, 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 dum. Hey, YouTube just told me I'm live on my channel. Hey, very good. 5, 4, 3, 2, 1, and welcome to our second Boring JavaScript Project's live broadcast. This is TheVirtuoid, aka Mike Smith, and I thank you so much for joining us tonight. So today we are going to cover the JavaScript Snake game. Now, I know last month we already did one, but this one is going to be in 3 dimensions. So instead of having a flat snake trying to chase that little apple through the screen, now you're going to be in this large 3-dimensional cage. You are going to be the snake at a first-person view as you travel through the cage trying to find that apple. You'll eat the apple, and as you eat the apple, your tail will continue to grow. But watch out for the sides. They're electrified, so if you hit the sides or if you eat your tail, the game is over. So this is basically taken, to use the pun, the game to another dimension. So let's go ahead and let's take a quick look at some of the technologies we're going to be using today. First of all, in JavaScript itself, we're going to be concentrating heavily on modules. Now that's, of course, something that is relatively new to JavaScript. And I really encourage you to start learning how to use modules correctly. This saves you from having to throw all of your JavaScript files into one giant script tag, which is the way we used to do it years and years and years ago. We're going to be also doing a lot of classes. Each of the classes are going to handle a specific piece of the game itself, from the game to the snake to the board to cameras, lighting, all that kind of fun stuff. Also, we're going to be dealing with local storage. Now, I did a Boring JavaScript video 2 weeks ago on local storage, so I encourage you to go to www.boringjavascript.com and take a look at it. But basically, local storage allows us to create persistent values in the browser. So if you play the game and you're finished, you close out your browser, and a month later you play the game again, the settings you've put in there will still be there. So that's basically what local storage does. Now, we're going to do some front-end tooling called Vite and some a graphics engine called BabylonJS. Now, anybody who knows me, who's worked with me before, knows that I do not like using libraries at all. I like to program my JavaScript in basic form so it's as fast and as efficient as possible. But the fact of the matter is, there are some technologies that are way beyond your capabilities, and graphics are way beyond mine. It would take me 6 months to a year to figure out how to get a 3-dimensional system working on a 2D graphics. So using something like BabylonJS is a wonderful way of getting into graphical programming and game programming, for lack of a better term, into JavaScript without having to spend years learning all of the graphic bases to it. Now, why BabylonJS? Because I'd never used it before. If you're used to using 3JS, great, go ahead and do it. I used 3JS a couple years ago and it was great, but I wanted to use BabylonJS because I'd never used it. Vite is my front-end tooling. If you're familiar with Webpack, it works exactly the same as Webpack. In fact, I use Webpack at my Pay the Mortgage job. I'm using Vite this time because I'd never used it before, and it's written by the same people who wrote the Vue framework, and I really, really love the Vue framework. Its simplicity and its simplicity, it's ease of use. So those are the technologies we're going to use. Let's get into the classes that we're going to be working with today. We're going to be creating 8 classes within the JavaScript. Our first class is the game class, and it's going to control everything. Its purpose is to instantiate all the other classes, start the game up, keep score, know when a hit is going to occur, stop the game, and then ask you to play again. It's also going to be responsible for making sure that it launches the classes that will allow you to change settings. The 3 classes on the left there, the camera, the light, and the game sound, are very small classes that will support certain BabylonJS functions, and we'll get into that in our next slide here in just a second. The configuration is our only class that has nothing to do with BabylonJS, but its entire purpose is to bring up a dialog box that allows you to be able to change settings for the game here, and we'll show you that here as we demo the game a little bit later on. The board, the marker, and the snake are the 3 most important classes. Those are the ones that actually draw things out on the screen and allow you to interact with the screen itself. The board is our cage, and our cage basically is, if you think of it, we're inside of a cube. And this cube, of course, has a front and a back, two sides, a top and a bottom. And we're inside this cube. And we're pretending as if all of these sides are electrified. And you'll see that once we get into creating the board. The marker is the apple that we eat. And I called it marker and not apple because I envisioned later on down we might have watermelons or cucumbers or bananas or any kind of fruit. So by calling it a generic name, I kind of give the ability to be able to make modifications to it later on down the road. And finally, of course, there's the snake class. And the snake class is what's responsible for creating the snake, growing the snake, moving the snake through the board, and also determining whether we've hit its tail, we've hit the board, or we've hit the marker. And that's basically it. The game launches everything on there. Now, very quickly on BabylonJS. Now, like I said, I've never used BabylonJS before until literally a month ago. So I'm not going to be teaching you how to use BabylonJS here. I mean, that would take a long time. But BabylonJS has a fantastic documentation system, so I encourage you to Google it, look it up, and start using it if you want to learn more about it. But I'm going to kind of give you a very quick idea of what parts of BabylonJS we're going to be using. The engine and the scene are two of the most important ones. The engine runs everything. Basically, you tell the engine, hey, start running my scene. And then it will attempt to do it 60 frames per second or as fast as it possibly could. So the engine's going to run everything. And you'll see that when we get to the code. The scene is going to contain all of our objects. It will contain the cameras, the lights, the board, the snake, the marker. And so that's where all of that's going to be put on. The camera allows us to see everything. If you don't have a camera, you can't see anything. Light allows us to light up the scene. If there's no light, you can't see anything. So the camera and light are going to be very important to this. Mesh, material, and texture are three very important things. The mesh is the actual model that we use to display the screen, to display an object. For example, we have an apple model, and that's called a mesh. We have a board, the 6 boards that represent our cube, that's a mesh. We have the snake, which is a whole bunch of small little segments of meshes. Those are meshes. But a mesh is kind of like the studs of a house. You can take a look at a house in construction, you can say, oh, yep, that's a house, but once you get in there, you really can't tell what's going on just because all you got are studs. Well, the mesh is the studs. What gets put on the studs is the material, and the material defines, like I said, what gets put onto the mesh itself, kind of like drywall onto a house. So you put the drywall into the house, now you start to see the rooms, but everything is white and blank and it looks terrible. So how are you going to fix that? Well, you paint the drywall. And that's the texture part. The texture part is what gets put on the material, which gets put on the mesh to allow you to be able to color the mesh. Or in my case, to put images onto the mesh. I have a snake image, a snake skin image, an apple image, and an electric fence image that I'll be using for all 3 of my boards. So that's kind of a very quick synopsis of how we're going to be using BabylonJS. So let's get to the actual coding here. Now what I have done is I have gotten a system already set up here, the way I like to set it up with using the Vite. I have a distribution and a source directory, and all these files here are just support files to allow me to be able to use Vite and be able to get the modules from BabylonJS and all that kind of fun stuff. Don't worry about it. But within the source directory, I have 4 other directories. I have my CSS directory, which is my style sheet, and that's my style sheet. By the way, I'm using Sass here. I love Sass, and my WebStorm IDE automatically compiles that for me. Here's my image directory, and all of these images here are my textures that I will be using for onto the materials, with one exception. That's the watermelon.glb. That is actually my mesh for the apple. They called it a watermelon when I found it on a free site somewhere, but it looked more like an apple to me, so I used that instead. The JavaScript is where all of our JavaScript is going to go. Right now there's just one file in there. That's what's associated with our HTML, and I'll show you that here in just a second. And finally, our sounds directory are the 3 sounds. Babylon will also play sounds for you. So I've got a sound when you hit the marker, I've got a sound when you hit the board, and I've got a sound when you eat your tail. It really sounds great here, and I got my computer turned up all the way so we can hear it. So there's my index.html. Let's take a quick look at that because it's not going to change once I've got here. What we're going to see here. There's just my CSS. This is just normal HTML here. Here's my script tag. Notice it says type equals module, and that basically tells JavaScript, hey, this is not just your normal JavaScript file that you're used to. This is a module that we're going to be loading in. So it's going to load it into its own little own space within JavaScript. And from that, I can then call other modules, which each one of these classes will be called as a module. This is going to be the section that contains all of my data. This will keep count of the score. This is going to be our start button or our play again button. This is going to show us our FPS, and that will become very important later as we try to do debugging to know what the FPS is like. This is our important part here. This is the canvas. This is an HTML element that allows us to draw graphics on the screen. And this is what BabylonJS uses to draw all of its graphics. And here's our configuration program of HTML, which again I'll show you. We'll show you that once we're done. Our HTML file is not going to change. I'm not going to show you much anything here. Now, we do load in the snake3d.js. Let's take a quick look at that. This is also not going to change. All it does is import the game. This is how you type it. This is how you import modules inside JavaScript. So I import the game. I instantiate the game, pass in the canvas, and then I start. That's it. There's nothing else. Like I said, the game controls everything. So the game will then run its start method, which will instantiate everything, initialize everything, and then play the game. So let's get started. So what I'm going to do is I'm going to go through each one of the individual modules here with the exception of game and just kind of load them in and give you a brief explanation about what's going on. So let me just get my system up and running here. First thing I want to bring in is the camera. And I'm just going to copy it. I've got another copy, by the way, of the project on another WebStorm system here. Okay, so this is the camera. And the camera class is very simple. It uses what's called universal camera. And this is what BabylonJS says that is you need to use if you're going to be using first-person viewing of if you're creating some type of game. So that's no big deal here. So a couple of things I just want to show you. First of all, this initialize section. Every one of my classes has an initialize section. This allows us to be able to reinitialize any kind of data. In case we want to, after you finish your game, you have it play again, you want to reinitialize the data, make sure everything is set up correctly. But I want to show you it's doing a promise.resolve at the very end. And that's very important because the promise.resolve basically says that this is going to be part of a promise routine. And that's going to get very important in the game section because I want to be able to initialize everything and then allow you to start the game. I don't want you to be able to start the game before everything finishes initializing. So I'm using promises here to fix that. And once we get to the game part, I'll show you that. The other thing here is real simple. Is just BabylonJS gives me the ability to move meshes very easily. So this section allows me to move the camera itself. Obviously, since we're first-person view, we got to move the camera. And that's really about most important things there. There's really not a whole lot to the camera class. So let's bring in the light class. Now the light class allows us to be able to see everything inside the scene. We've got to light things up, so we use a light class, and it uses what's called a hemispheric light. And there's a lot of different lights in BabylonJS, and I played with all of them, and this is the one that worked best. With one exception, I'll show you here in just a second. But there's not a whole lot you can do with this. Not a whole lot to do with this here. You've got three different colors you can give it, and I played around with until I got something that colored up my marker and my snake, I thought, rather nicely. I do have a routine here called exclude mesh because I did find out it didn't work on the boards very well, so I have the boards do their own lighting, and I'll show you that here shortly. But that's all there is to the light. There's, like I said, there's some of these, there's really not a whole lot of class to them. Or not a whole lot of class, yeah, that's right. There's not a whole lot to them. It just gives us the ability to wrap stuff around these objects that BabylonJS gives us. So that's the light. Let's now take a look at the game sound. And if you thought that was a really simple and easy one, wait till you see this one. Here's the game sound. BabylonJS gives us the ability to play sounds. So I am setting up a map object. This is a new way of declaring containers within JavaScript. And I'm setting a key called board, a key called marker, and a key called snake to play these three particular MP3 files. And all you have to do in my code here is just say, hey, play, and that's it. And you pass a target, and that target's either going to be board, marker, or snake. And then it will play the sound. And that's it. There's really nothing, a whole lot to it. Nothing to say past that point. Let's go to the configuration. Whoops. Let's actually try to drag it over correctly. Let's go to the configuration. The configuration does not have anything to do with BabylonJS, but its purpose is to bring up a configuration window in which you can set different parameters. So I'm not going to go through all this, but there's something very, very important here that I do want to show you. And that's these two lines right here. This first line here at line 64, this is the local storage. Like I said, local storage is using to save persistent values. So the configuration class's responsibility is that after you type in all the information and you close the dialog box, this will automatically save all your information to the local storage. So that next time you play the game, when it reinitializes at line 68 here, it's going to get the JavaScript Snake 3D information from the local storage and then figure it all out for you automatically. And also the initialization section here will also automatically save it, automatically create that entry for you. Because again, local storage will allow us to persist those values so that if you play this game again a month from now or a year from now, they will still be there unless the application deletes them or unless you delete them yourself. Other than that, this is just a very simple bring up a dialog box, type in some information and close it. So I'm not going to go through it much more than that. So let's get to the three really nice ones. The first one is our board. This is going to be our board itself. And the first thing I want to show you is that the board is sized of 40 units. And to give you some perspective, each small segment, the snake is made up of a bunch of different segments. And each segment of the snake is a sphere that is 0.25 units in diameter. So as you can tell, 40 gives you quite a bit. And when you see it on the screen, it doesn't look like a whole lot, but in actuality, 40 gives you quite a bit of distance left and right, forward and backward, up and down. So that's the size of it. But the key here is that, first of all, here's my setup. We're inside of a cube, so I have 6 walls. I have a wall here, a wall in the back, a wall to the right, a wall to the left, a wall above, and a wall below. But when I create these walls, it's going to create it like this. And that's great for this wall and great for that wall, but it doesn't work for this wall, this wall, this wall, or this wall. Because when I create it, it's going to look like this, and that's going to look terrible. So I need to rotate it this way. For this wall, I need to rotate that way. For that wall, rotate this way. For this wall, rotate that way. And that will give me my enclosing sphere. So with this whole 6-item array that we have here, gives us the position of all of the different places that this wall will be, the size, which is 40 units. Some of them have a rotation on them, which will allow me to rotate them a certain way. Some of them do not. This one does not, and this one does not, which means basically those are the two that are going to be in front of me and back of me. All the rest of them are going to rotate. And then it's just a real simple matter of creating what we call the tiled plane. And a tiled plane basically says that when I take my texture, which I'll show you here in a second, instead of just making the texture the entire size of the mesh, in this particular case, it's going to tile it within the mesh. And that allows me to kind of get this electric fence mesh correct. Electric fence mesh looking correctly on the screen. And then all I do is just set the material and set the position, and if it rotates, I rotate. Then I exclude it from the hemispheric light. And the reason I do that is if we go back up to the top here, here's my material, here's my texture, but I'm calling it an emissive texture. And this is something that BabylonJS allows me to do, to be able to say, hey, this texture is actually going to emit its own light. So I discovered that it looked really nice if I had the texture emit its own light. And that's what this whole section up here does. Because remember, a texture goes onto a material, and a material goes onto the mesh. So this creates all the meshes for the board. This will create all 6 of them and rotate 4 of them to where I got a nice and pretty little cube there. And that's pretty much all there is to the board. There really is nothing else. So let's now get to the marker and show you what that looks like. And this is also an extremely simple one, because the whole purpose of the marker here is to be able to randomize a place where it goes onto the screen and place it on the screen. And it's really not much there. You got the standard material and the texture, and this is where I'm loading in the Apple JPEG. This is the set position, which does a randomization of the X, the Y, and the Z coordinates for the Apple, and will randomize it within the sphere itself. There is a to-do here about making sure it doesn't hit the snake, I will leave that for you later on to be able to figure out, mostly because I ran out of time to get it working. But I'll show you what you need to do there. But earlier I had mentioned that all initialization has to complete before we start the game. And the reason that occurs is that we're importing a model from the system. This is that watermelon.glob that I've just highlighted on the left. We're inserting that model, and to do that, that is actually an asynchronous operation in BabylonJS. That's the import mesh option. And remember, asynchronous basically says it's going to go off and do something and then tell you later on when it's done. And in this case, it's going to do the onSuccess method. And when that onSuccess method is executed, that means it has successfully loaded up the mesh. And in that case, I do whatever I have to do to get it set correctly, and then I resolve my promise. So this allows me to basically, as we'll see here shortly, this allows me to be able to initialize all the different objects and then wait until they're all done until I initialize the start button and say, okay, you can now start. And I'll show you that here shortly. But the whole reason that we're doing all this asynchronous promises and all that kind of stuff on the initialize is simply because of this. We need to be able to wait until this is finished before we continue and initialize the rest of our system. And that's really all there is to marker. There really isn't much left there. Now let's get to the snake. And there's really not a whole lot there either, but I kind of want to show you just a couple of things. The snake, there's a couple of things I want to kind of talk to you through here real quick. First of all, it has a diameter, and that's passed to us by the game. And like I said, the diameter is 0.25% of a unit. We're 40 long on, or our units are 40. The distance between one wall to the other is 40 units, and our snake is 0.25. And we are creating, let me go down to the new segment here. We are creating a sphere for each segment. So what the snake does is it has a segment there, and then it will put new segments into itself as the snake grows. So instead of trying to figure out how to stretch a mesh and doing, and that was way beyond me. I figured it's just a lot easier just to have just a bunch of spheres occurring with the snake, and actually it came out pretty good. As you'll see here in just a second. So the idea here is that the snake is actually made up of a bunch of different circular meshes, each one covered in the snake skin texture. And as the snake moves, it will add to the tail. And all of that occurs right in, actually, let's go to the move first. All of that occurs right here within the move method. And the move method basically will move the snake and then add a tail segment if necessary. Now, one of the things you have to think about when you're designing games like this is what's the most efficient way to be able to do something. And when you first think about this, you're sitting there thinking, okay, I've got 5 segments in my snake, and the system is running at 60 frames per second. I should be able to move all 5 of those segments within that 60 frames per second, no problem whatsoever. And most likely you will. That's no big deal. But then you got to think about scaling factors. What if you had 100 segments, 200 segments? I had 4,000 segments in one of my tests one time. What happens if you try to move all the snake at one time? You're going to crash your computer. I mean, BabylonJS is just going to go, oh, I can't do it for you like that. So that's just not going to work. So you got to try to think this thing through. And the solution that I came up with was real simple. So when we're moving the snake, we got to make it look like we're moving the snake. And the easy way to do that is let's say this is the head, and this is the snake, and this is the tail of the snake. Here's the head. The head has moved to the next position. What we're going to then do is insert a new snake segment right here, because we don't want the head detached from the snake tail. A new segment gets put in right here, and the old tail gets removed. And what's the result of that? Head, new, remove. 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 Head, new, remove, and on and so forth. So what it looks like at 60 frames per second is it looks like that the snake is just moving through time, when all that's really happening is the head is moving, I'm inserting a new segment, and I'm removing something off the tail. And if the snake has to grow, I just don't remove it off the tail. It's that simple. That way, I don't have to move the entire snake all the time. I just have to move 2 segments. I got to move 1 segment at the top, add a segment, and remove a segment at the end. Do you think it could do that in 60 frames per second? Yes. And I can tell you right now, although it started kind of getting a little dicey on me around 3,000, it will do 3,000 segments and work like a champ for you. And I think the way it wasn't quite working, it was kind of going a little bit like this was mostly my fault. But that's neither here nor there. But that's one of the things that you kind of think through when you're doing these kind of designs is what's the most efficient way to update the system without bogging it down. And that's one of the ways that you can do it. So that's the whole purpose of this add tail segment here. It gets the new segment. This is the new segment. It clones the camera position, and then it just adds it to, here's the clone of the camera position. Here's where it sets the position of the new segment, and then it just puts it onto the tail, and the tail is just an array. If I don't grow, I just pop it off at the end of the array and dispose of it. That's it. If I do grow, then I don't pop it off. Now, I have a growth counter here because I found out, if you eat an apple, you just don't want to add one segment like we did in the 2D game. You'll be here forever. So I add literally 50, 100 segments at a time in order to grow the tail. It makes the game run a little faster. It makes it much more fun to play. So the whole idea here is that what we want to do is we just want to move the head, pop a new segment, and take one off the end. That's it. And it will run perfectly like a champ. The other thing here is how to do hits. How to do hits is also extremely important because you run into the same problem here. Let's say you had 600, 700 segments. Now hitting a board, knowing you hit a marker is easy. Knowing you hit a board, one of the 6 boards is easy. But how do you know which of the 500, 600, 1,000 segments you hit? Well, you can't sit there 60 times per second, test each and every single one of them to see if you hit it. It just doesn't work. So what you want to do is something called ray tracing. And what ray tracing does is if you take the head of which is the camera basically, if you take the head of the snake and you imagine it shoots a laser out from the head of the snake, it's a bionic snake. You shoot a laser out from the head of the snake. What that laser will do is it will continue on until it hits something. And what's it going to hit? It's going to hit either the board, it's going to hit our marker, or it's going to hit our snake. Once it hits something, it then reports back to the head saying, hey, I've hit something. Then the head's responsibility says, okay, if that something is within a diameter of me, then I've actually hit it. If it's not within a diameter of me, then I haven't hit it. Because if you're 20 units away from the board, it's still going to say you've hit a board because it's eventually going to hit a board. But that board is 20 units away and not 0.25. So you know you're still okay. And so that's what this little section does here is that if we actually get a hit, we test the diameter. And in BabylonJS, they give that to us with called a ray class. And it's wonderful. By giving an origin and a direction and a length, which my length is 40, it works like a champ. It works great. And it is fast as all get out. Now, I have to admit, when I got it to about 4,000 units, 4,000 segments in the snake, and I got way up high and looked down on this cacophony of a mess there, my FPS started going down a little bit. But I think that's more of my programming than it is anything else. But I'm not going to worry about that. But ray tracing is a fast and convenient method to determining if you have actually hit something. And it'll work if you have 10 segments, 100 segments, or even 1,000 segments. It will work like a champ. So those are the really important things on the snake, except for the initialize. Initialize wipes out the old tail and recreates a new tail. That's no big deal. Not going to worry about that. So we've gotten all the classes in there except for the game class. And how do we know that we have no game class? Because if we flip over to our browser sits here and says, I can't find the game from snake3d.js. Does the file exist? No, it does not exist. So obviously nothing works at this particular point in time. So let's flip back over to our code and let's get down to the meat of everything, and that is the game class. Now the game class, again, is responsible for instantiating all of the other classes and is responsible for controlling the game itself. It's responsible for starting the game, initializing all the classes, allowing us to be able to hit the start button, running the game itself. It tells that BabylonJS to run the game. It's determining when a hit has occurred, and when a hit has occurred, it stops the game, tells us that you want to play again, and then repeats the process over and over until you exit out of the browser. So let's get to the game. And what we'll do here is we will create a new JavaScript file. Now you can't see that for some reason. I don't know why WebStorm doesn't show this part, but this is just a dialog box. It's an empty class, so let's create the class. Oops, let's go default first. Class game. Let's start putting some stuff in there. First thing I'm going to do here is we got a lot of imports because again we're doing modules here, so every module within JavaScript is imported. So here are all the different modules. These are all the things that we're using from BabylonJS within this game here. And this is our 7 classes that we've created ourselves that we just went over very shortly here. So let's start putting some code in there. The first thing we're going to put in there are all the properties. Let's put the properties in there. I'm not going to go through these that much, except that we have the scene in the engine that's extremely important to BabylonJS. This basically is the main way we tell BabylonJS needs to do what it needs to do. Here are all of our instances for the different classes, and here are all the parameters that we're going to be using within the game just to be able to control the game. These are, for instance, these are our 4 pieces of data that you're going to be able to configure in the configuration screen. And the rest of these things are just kind of, helper variables to assist us and to pass along to classes and to assist us to be able to get everything running. So let's now do our constructor. And our constructor is going to take a canvas DOM variable. And let's start throwing some stuff into the constructor real quick. And what I'll do again is I'll copy this one at a time, and we'll show it to you on the screen one at a time when it actually gets to a point to be able to show it to you on the screen. So, most important thing here is that we got to set up the engine and the scene for BabylonJS. This is how you do it in BabylonJS. There's my new engine, there's my new scene. The engine controls the scene contains all of our objects, so it's extremely important there. Here's some pointers just to some DOM elements, especially the start button allows us to be able to change, click on the start button or to change it from the word start to play again. And this sets up our configuration screen itself. And the configuration screen, again, I'm not going to go through until we actually do the demo here. I need to add one more thing here called change configuration. This is a event handler that is fired off from the configuration class to be able to say, hey, you've got a configuration change, you need to do something with it. So let's go ahead and put that code in there, and then we'll just forget about it until a little bit later on. And we'll forget about it at that point. Okay, if we go back to our snake.3d game, to start the game, we have a start method. So guess what we're going to add in? That's right, we're going to add a start method in. Our start method is going to call our initialize method. Initialize. We don't have an initialize method, so let's create an initialize method. And a lot of this will come clear once we start getting more code in there. The initialize method is going to launch the game, and that's going to be the go method. Well, we don't have a go method. Looks like we got something misspelled. Initialize. I've got something misspelled here. Somebody help me out. Somebody help me out. What have I got misspelled? Initialize. Ah, there it is. Ta-da! I can't spell to save my soul. Okay, so initialize is initialize. We have to have a go method. There's our go method, and I'm going to copy this one little section from the other code because I want to explain what happens here. The go method is what we need to be able to call what's called a run render loop on the engine. This is what BabylonJS is. This is how we tell BabylonJS to say, okay, run that animated render loop as fast as you possibly can, which is 60 frames per second. And within that render loop, we're going to run the render method. And the render method on the scene basically says, okay, take all the objects for the scene and render them onto the canvas. So this is how BabylonJS runs a system, basically displays animation and displays everything onto the canvas. Couldn't be easier. All right, we got a stop method, which we're not using right now, but I'm going to pop it in there anyway. Stop. All right, we've got a stop method, and that's pretty much it. Now, if you were to run this right now, which we're not, but if you're able to run this right now, it will give you an error saying that the camera cannot be found because you got to have a camera with the scene. Obviously, the camera is your eyes. If you have no camera, you can't see a thing. So you got to have some sort of camera. So let's put the camera in there. Da-da-da. This is where it's going to get really easy. So basically, after we do each one of these, we're going to run the program. So that's how we do the camera. I'm just instantiating a new camera instance. And what we have to do now with the camera is put it inside of the start function. So the start function is going to change just a little bit more than what it is now. Let me just copy that information over here real quick. And it's in 3 little pieces. And this is where I'm going to explain what the initialize, why the initialize is, all the initialize on the classes are built the way they are. And let me just pop over the camera one real quick. Now what I've done here, remember all the initializes in all of the different classes are promises, and they all do a promise resolve eventually. For all of the classes except for marker, it's immediate promise resolve, but the marker has a promise resolve once it loads up the model. So what I've done here is I'm going to have an array of initializers, and I'm going to push to this array all of the different initialization methods for each of the classes. And then I'm going to run what we call a promise all. And a promise all tells us, or in JavaScript it says, okay, once every single entry in my array has resolved, then do this part. So basically what I'm going to do here is that once all of that has been resolved, then I want to be able to run my initialize routine. And in my initialize routine, I'm going to do the start button and all that kind of fun stuff. Right now it just does go, which is all we really need. So we're going to be adding one at a time. As we add everything one at a time, we're going to be adding stuff to the start button here. So that gets our camera. So technically at this particular point in time, we should be able to run the program. Let's go over to our browser. Let's see what happens. Let's do a Control F5. And nothing happens. Why not? Well, think about it. We have a camera, but we have no lights. So let's pop a light in there. Let's get back over to our code. Let's throw a light onto the scene. Da-da-da-da. Back up to the constructor. There's our light. We're just instantiating a new light. Let's throw the initialize in there because every one of them is going to be reinitialized. So as you can tell here, we're going to be building the start method one at a time for each of the classes. So that's all there is to the light. Let's run that and see what happens. Let's go back over to our browser. Let's do a Control F5. And there we are. Nothing's there. Why is nothing there? Because we have a camera, we have a light, but we have nothing that gets lit up. So let's now actually put something on there. And what we're going to put on there is the board. So I'm going to flip back to the code. And let's put our board. And then remember, the board is our cage, our sail, our six-sided sail that we're going to be within. And this is going to be the first time you're actually going to finally see something here. So let's copy over the board information for the constructor. And I'm just instantiating an instantiation there, instantiating the class. And let's get our initializers here for the start. Let's put that in there. Now we're initializing the board, and that should be it. So let's now flip back over to our browser. Let's do a Control F5, and there it is. We got something on the screen. Woohoo! This is my electric fence. What I'm going to do here is I'm now going to click and hold the mouse button inside of the canvas and then move the mouse. And as I do that with this camera, as you can tell, it does move everything around. I'm going to kind of go a little bit slowly here. Kind of hard to see because the fact of the matter is I really suck at doing graphic design and things like that. So, you know, I just grabbed something, threw it on there. I guarantee you there's people out there who know what the heck they're doing, can make this look a lot easier. And if you can, be my guest. But this is our fence. So look what happens when I move. I'm going to use the arrow keys to move. And we get to the move. Uh-oh, what happened? Well, what happened is that there's no collision detection there. So it's just a free-form collision. So I'm going to flip back over to the cube, get back in there. Collision detection happens at the game level. So there's no collision detection. So we actually got something we can see on the screens. Let's flip back over to the code and let's add something else. How about the marker? And the marker is the apple. So let's put the marker in there. We will go to the constructor, get that in there, go to our start button, throw the marker inside there. And we're going to do one additional thing is inside the go routine. Where's my go? There it is. Inside the go routine, we've got to use these, we're going to set the set position of the marker, and set position in the marker, and I'll show you that here real quick. We'll show it to you again here. Randomizes a position somewhere inside of the cage to be able to place the marker. So every time you hit F5, you'll see a different marker. Let me get back. Where's my game? There it is. Get back to the game. And so that's it for the game marker there. Let's flip back over to our browser. And let's do a Control F5. It's already done, so let's see if we can find our marker. Oh, there it is. Oh, I found it quick. So let's use the arrow keys to get closer to it. Oops. There we go. There's my marker. There's my apple. Like I said, graphics stink, but hey, it's still an apple. Oh, what happened to the collision? Well, remember, no collision until we get to the game class. Game class controls the collision, so it's going to go straight through it right now no matter what. But that's what our apple looks like. And it looks just like an apple. It's really, really cool. So let's flip back over to the code. We've got the apple in there, and let's now put the game sound. And you're going to really love, whoops, I almost messed that up. Hey, hang on. I almost copied the entire JavaScript file over to my game section here. My bad. All right, hang on a second. Let's see. Got that game sound. All right, so let's go to our constructor. We construct a new game sound instance. Let's initialize it. Where's my game sound? There it is. Let's pop an initialization on there. Let's save it. Let's flip back over to our browser. And let's see what happens when we hit the fence. Let's see if we can hear anything. Oh, why didn't we hear anything? Because remember, collision detection is inside the game. Collision detection determines the sound. So there is no sound right now. I mean, there is sound, it's there, but it's not being played because there's no collision detection. So let's flip back over to our code. And now let's add Mr. Snake inside there. So let's pop the snake in. And the snake is right here. So this is go to the constructor. There's our snake. We're passing a lot more to the snake than normal. We're passing it the diameter, which is 0.25. And that's defined in those properties way at the very top there. A speed of the snake, and one of the things that you could do later on is to be able to put different speeds inside there. And the number of starting segments is interesting. What I found out, if you start out with like 5 or 6 segments, which is what you'll do in the 2D game, this game gets very boring very quick because, remember, we're geometrically making the thing huge. So the starting segments could easily start at like 100 segments, and then it can grow by 100 segments each and every single time you eat an apple, and it would make the game more fun to play. So, but this starting segments allows me to pass the starting segments. Let's set up the initialize for the snake. And in reality, that actually completes our start routine completely. And I think that's all we're going to need to do. Yep, that's all we're going to need to do. So let's save what we got, and let's flip back over to our browser. It's already initialized for us. So the only way to see the snake, because nothing is moving and the snake is basically created right on top of us, so the only way to see it is I'm just going to back up a little bit. Of course, I got to click inside the canvas first. Back up a little bit. There it is! There is our snake. Now, I love the snake skin. The snake skin came out great, and I've got some comments in the code there to say who it came from, to give them rad credit, because I love the snake skin here. But this is the snake skin, and what will happen is that as the snake grows, each segment of the snake will be that sphere that you see right there. So a 5-segment snake will have 5 spheres, 100 segments, 100 spheres, all lined up one right after another as you go through the entire maze there. So that's what a snake skin looks like. But obviously, collision still doesn't work. Why? Because the game controls the collisions. So that takes care of the initialization for all of our classes except for one, and that's our game class. Let's actually now put this thing together and get a working version ready to go. So what we'll do is we'll skip over to the code, and let's start putting some things back in there. I got a couple more lines that we need to throw inside the constructor. And those are real simple. It just basically gives us be able to point to the FPS DOM so we can update that FPS. But most important is this register before render and this game runner function, which we'll be adding last here. Now what this is that this allows me to register a function with BabylonJS to run just before it does, let me go down to the go, just before it does the this scene.render. So by setting this with the register before render, it says, okay, I'm going to run this function, which we haven't added yet, before I do this one 60 times a second. So what's going to happen in here? That's going to be where all the magic occurs. That's where we're going to have the moving of the snake. and the determination of if we've hit something or not, the additions of the score, and whether we stop the game or grow the snake or whatever. So game runner is going to be the most important function here, and that's going to be the last thing added, because once we get that added, the game's pretty much finished up and ready to go. Okay, start, we don't need anything on. Initialize is going to change a little bit here. I think it's going to change a lot, but you'll see why in here in just a second. Now, basically initialize, the whole idea here, let me go back to start. The whole idea on start here is that we are initializing all of our classes, and once all of them are initialized, and we know they've been initialized by the promise.all, then we initialize ourselves. And when we initialize ourselves, we just set frame rates, we set the score back to 0, we change it on the DOM, we change the content of the start button to start, and the most important thing here is this part right here. We're doing an add event listener for a click. So when you click on the start button, it goes to the go method. Because remember earlier, initialize just said go, and that's all it did. But now we've got it to where it won't happen until you click on start. So what will happen if you ever start this game, it'll say, please wait up there, everything's going to be disabled, and then after a second or two, depending upon how much you're initializing, it will then flash start. So that's a way that we can sit there and using start up here to know when everything's been initialized, and once it has, we then change the start button to say start, and you can then click on it and go in that case. So speaking of that, let's do the go. And it's going to expand a little bit longer because Go has a little bit more to do. But in reality, it doesn't really have a whole lot to do. First thing it does is it disables the start button and the configuration button, because I don't want you to be playing the game and then suddenly want to hit the start button again or want to hit the configuration button. So I disable those two buttons on the DOM. There's our set position like we had before. Request pointer lock is very important because with BabylonJS, what you have to do to move the view of the camera is to click inside the canvas, click and hold, and then move your mouse. Well, that's highly inconvenient. So the request pointer lock ties the mouse movement into the canvas. And by doing that, it automatically means every time that mouse moves, it's as if you're holding the mouse button down and you're moving the mouse. So it basically takes control of your mouse away from you and puts it into the canvas so that any mouse movement you do is associated just with that canvas. Here's the unlock. The unlock basically is something that we need to do here on the engine to be able to play sounds. And of course, here's the render function that we've all know and love that we've seen before. Let's go ahead and fill in the stop, because obviously that game runner at the top is going to have to stop everything. So let's fill that in. And obviously in stop, we're going to stop the render loop. Why do we stop the render loop? Because the game is over. Why render the screen more if we have to, if we're not running the game anymore? So we do the stop render loop. Well, also remember, our mouse is now controlled by the canvas. We want to give it back to the user, so we exit the pointer lock. That now makes your mouse available to you, and because of that, we now enable the start button and the configuration button. We do change the name of the start button to play again, and when it does do a click, notice it calls start again. So by calling start again, it goes back up to the top for start. Start does initialize. Initialize says, hey, click the start button to start again. When you click the start button, it runs the game until it stops, and then it says play again, and it just goes on and on into a nice little fun little loop at that point. So that's go stop. So let's do the big one, Mr. Game Runner. And again, Game Runner is a routine that is called before every single render on the within the code, within the game. And that was set up back here in the constructor, where I say register this function to be run every time BabylonJS calls the render method. Let's see what it does. And actually, it's real simple. The real big thing here is this section right here, line number 152. This moves the snake, but the snake, when it moves, returns a two key value pairs. And those two key value pairs, the one key is called marker, and it's either true or false. If marker is true, that means the snake actually hit a marker. If the other key value is called other, if other is false, it hasn't hit something else. But if it is not false, it is either going to have the word board or it's going to have the word snake in it. And so basically when we do the move, in fact, let's just bring up snake.js here real quick. Where is it? Yeah, here's the hit. So basically the hit here, this is where it gets set. And this whole set here basically says marker is either true or false, whether you hit a marker or not. Other is either false or the name board or the name tail, snake. And that corresponds to the game sound over here of board, marker, and snake. See how that works? So going back over to game, if I've got a hit of other, that means I have hit either a snake or I have hit the board. So I play the game sound and I stop the game. That's it. Game gets sound, stop game. If other is false, then it goes to marker. And if marker is true, I reset the position of the marker, because remember, set position just randomizes a new position. I change the score, I play the sound for marker, and then I grow the next segment and I pop that value onto the score. And then of course the very final thing does, it just keeps track of my FPS. All right, technically, that's it. It should run the game perfectly at that point. Now this is assuming I've actually copied things. So the first thing I'm going to do is, let's go over to our browser. And I'm going to hit F12 so I know what the heck's going on here. Make sure I don't have any errors, because Lord knows I can probably copy things wrong. So the first thing you notice here is that, let me do a Control F5 again. Notice it says please wait, and then about a second and a half, 2 seconds later it says start. That's because it's going through all the initialization routines. So first thing I want to show you is the configuration. When I click on configure, which is the little tool set in the upper right hand corner, this is the things that you can set. Starting segments, I'm going to start with 100 segments, and the reason that basically means that when the game starts, as I move along, it's going to draw 100 segments out as the initial length of my snake. Every time I get a new, eat a marker, I'm also going to change that to 100, which means every time I eat a marker, I'm going to add 100 segments. Because I'll tell you right now, in the 2D thing, we added one segment at a time, and that was great for the small 2D, but I'll tell you, if you just added one marker here, because like I said, we've geometrically expanded the size, you're going to be playing all day long. So putting segments per marker at this large a number means you're going to have a little bit more exciting game. You'll get this, and we'll see the snake much faster. Sound on and off is good. Increasing speed is not available at this particular point in time, and the reason is that I just kind of ran out of time, and I wanted to have a more unified speed thing. That would be something for a little bit later on. But I want to show you, when I click on X, it's going to go through and reinitialize the snake, because and now the snake is ready to go. But if I click on the configuration again, notice it still is set back to 100 and 100. If I was to close the browser, which I'm not going to do this time because I got everything set up for the live broadcast. If I was to close the browser and run this game and run the game again, the configuration would still be 100, 100 because I have local storage set up in the configuration. So I just kind of wanted to show you that. Well, we got the start button. Let's see what happens. Here we go. I hit the start button. It's got the pointer lock, and we are off and running. And there's my marker. And I talked too fast, and it just zapped me. Did you hear that? I hope you heard that. It zapped me when I hit the fence there. So let's click on the play again button so we can play again. So I click on play again button. I click on start, and off it goes again. So let's see if we can find the marker. I think I just saw it there. So let's flip over, and where's the marker? I thought I saw it. There it is. Listen. Did you hear that? That's the sound that the marker makes when you eat the apple. Now my snake tail is 200 segments long. Remember, it started out to be 100, and it grew to 100. Here, oh, now we're into the corner. Got it. All right, so now we're 300 long. Let's do one more, and then I'll see if I can double back and see if I can show you what this tail looks like. Assuming I can find one more marker. There it is. Oh, Lord, right top. I missed! Oh, no! Well, we might be able to see the tail this time. Got it that time. All right, so let's see if I can show you the tail. We're 400 long. There's the tail. There's another good shot at the tail. So you can see at 400 long, it's still pretty short. If we find another marker, we'll eat another marker. There it is right there. So what I'm going to do here, that was, you heard the sound of the apple eating. I'm going to show you the sound of the zap again for the electric fence. And that was the sound of the electric fence zapping you again. So what I'm going to do here is I'm going to go to configuration, and I'm going to have the segments per marker at 300. That means basically I'm going to make it really huge just so you can see what the snake looks like. And then we'll crash into the Snake. So we click on play again, we click on start, and off we go. Let's see if I can find a marker here real quick, because that's going to increase it really quick. There's a marker. There's a marker again. So I've got 700 now. Let's see if we can find one more marker. Yep, there it is. And there's my tail. Oh, actually, let's get another marker. Let's make it over 1,000 now. Oh, I missed. Let's go back over to it. If I can find it again. There it is. So now we're 1,000. Let's see if I can get a good look at the tail this time. All right, come on. There we go. Oh, there we go. There's a good. Let's see if we can get to the corner and then turn back around. There's our snake tail. You can see it's kind of, there's a good view of it. Let's get it a lot larger here. There's a good view. You can kind of see it getting shorter and shorter. Let's just eat another one here. And now let's run to our tail. Which actually at this, it's actually a little harder than it looks. Here we go. Oh, I missed my tail. Okay, here we go. Hope I'm not making you dizzy. There we go, it just hit the tail. In fact, this is a good little segue here. So that basically shows you the game itself. This was a lot of fun game, but there's a lot of little things that you can still do with this game here. I encourage you to download or clone the repository, because the game basically is playable right now, but it has a couple of bugs in it. You can see one right here. As we crashed into the tail, we kind of cut into the tail. In fact, one time, if you remember, when we crashed into the fence, we kind of cut into the fence too a little bit. But this game was a wonderful exercise. If everyone learned 3D graphics, this game is a wonderful little exercise in that, because it used some very basic concepts here to get a fairly cute looking game up and running. It worked very nicely with that one. So let's kind of just recap here. On the game itself. As you can tell, see if I can get my pointer correctly. Oh, there it is, right there. As you can tell, that's the GitHub repository. Right now it is private. It will be public within 5 minutes after we finish this routine here. I've got to move everything over to the main branch, and I will go ahead and make that public. The code is completely free for you to use. You can do whatever you want to with it. Doesn't bother me whatsoever. I do request, though, if you do make changes to it, do a pull request. Let me take a look at it. Like, for instance, if you want to try to fix that cut part that I just showed you there, or if you want to put in some new options like for high scores or something like that, or please, if you want to put some better textures in there, do a pull request. Let me know. I'll be more than happy to look at it and put it in there, because the fact of the matter is, I do this to try to help you out and give you the ideas that you can use to help learn a little bit about JavaScript. And in this case, some 3D work here. I'm not an expert at it, but that's okay. If we all work together and we make changes and we save changes to this game, anybody else who comes to it will be able to learn even more. So please, if you make changes to the game, let me know. Do a pull request on it. I'll be more than happy to take a look at it. Or take the game, make $1 billion with it. I'd be happy for you, because at least I got you started on that one. So that's basically it for our JavaScript Snake in 3D game. This is Boring JavaScript Projects #2. My name is TheVirtuoid, aka Mike Smith. You can visit me at www.thevirtuoid.com. You can also view all of our Boring JavaScript videos at www.boringjavascript.com, or you can subscribe to our YouTube channel, which is probably how you found the link to this particular one here. So again, I'm TheVirtuoid, aka Mike Smith. Thank you very, very much for being here. I really appreciate it. I hope you have a wonderful evening, and I hope to see you soon.